So our main topic today is to talk about the real number system. But in order to do that, we have to first review sets and subsets. So a set is a well-defined collection of objects. Each object in a set is called an element of that set. If every element in set A is also in set B, then set A is a subset of set B. Okay, so let's talk about this. First of all, I have different categories here. I have mammals, animals, felines, and cheetahs. So the overarching thing is animals. Okay, so there are different types of animals. There are mammals, which basically have fur, have hair, and produce babies with ovaries, and then you have other animals such as reptiles and aves. Okay, so I'm gonna go ahead and put the mammals here. Okay, so all mammals are animals, but not all animals are mammals. One example of an animal that's not a mammal are reptiles. Okay, so mammals are a subset of animals. Okay, so every mammal is an animal. Next, I'm going to go down the chain. We're going to have felines. So feline could be a cat. So we could say a domesticated cat. We could say a tiger. We could say a lion. All of those are in the feline family. All right. Now I'm going to go ahead and put cheetah here. So a cheetah is a feline, but not all felines are cheetahs. Okay. A cheetah is a feline, a cheetah is also a mammal, and a cheetah is also an animal. So when you think about a Venn diagram like this, think about the thing on the inside is going to be included in all of the sets on the outside. So cheetah is a subset of feline, feline is a subset of a mammal, and a mammal is a subset of an animal. Okay? So kind of think about sets and subsets like that. All right? Now, let's go ahead and classify some real numbers. First, we have natural numbers. All natural numbers are numbers that consist, well, we could actually think about it a different way. A natural number is a number that occurs commonly and obviously in nature. Okay, so if you go outside and you take a look at trees, you could actually count trees. You can say there's 1 tree, there's 2 trees, there's 3 trees, there's 4 trees. So the thing about natural numbers is that it does not include 0. Okay, it does not include 0 because you can't really observe the number 0. 0 is just nothing. Okay, so when you think about natural numbers, think about whole numbers. We usually count with these numbers. Okay, now whole numbers are all natural numbers, but including 0. So we have 0, we got 1, we got 2, we got 3, etc., etc. So the main thing between a natural number and a whole number is the inclusion of this 0 right here. Okay? Now, let's think about integers. Integers include all whole numbers and their negatives. So we can start with 0 again, but we'll have 1, we'll have -1. We'll have 2, we'll have -2. We'll have 3, and then we'll have -3. So integers are just whole numbers and their negatives. Okay? Let's keep moving. Next, we're going to go over rational numbers. Rational numbers are any numbers that can be expressed in the term A over B. Okay? So 1/4 is a rational number. If you want to convert 1/4 into a decimal, that would be 0.25. All right, so those are also rational numbers. If you think about 4 over 1, okay, that's still a rational number. Yes, it's also a whole number, but it could be considered a rational number as well because it could be expressed in the form A over B. Okay, so you could think about your rational numbers kind of like your fractions and your decimals. Okay, next, we have irrational numbers. Oh, also, one thing about rational numbers is that when you do divide a fraction, these fractions will stop. So you could do something like 0.333, or you could do something like 0.452. Okay, 0.452 terminates, it stops. So it is a rational number. Now, 0.3333, which is equivalent to 1/3, that actually goes on forever. Okay, so it technically does not stop. But because it's a predictable pattern, we still identify it as a rational number. So in order for it to be a rational number, it either has to stop or it goes off in a predictable pattern. Now, when we keep that in mind, let's talk about irrational numbers. Irrational numbers are not a part of any of these sets. It's off separate by itself. So you can think about an irrational number as pi, 3.14, and then it just keeps going and going and going in an unpredictable pattern. Also, you could think about 2 pi as an irrational number. All it means is that this unpredictable pattern is going twice as long. Okay? Another example of an irrational number could be something like 1.47623, and it just keeps going on forever and ever, and I'll indicate that by these dots. This would also be our irrational number. So irrational numbers do not terminate. They just keep going on forever when you're dividing. Now, all of these right here, these 5 categories, are all a part of the real number set. So we could basically define real numbers as the set of rational numbers and irrational numbers. Okay? So that's basically all of the definitions and some quick examples. Now, let's actually go ahead and put this into practice. So if you're giving a worksheet or something like that that has a real number system diagram, this is what you'll have to do. First of all, the overarching theme is the real number system. Like I said, the real number system consists of 2 things: rational numbers and irrational numbers. And as you can tell, irrational numbers are not a subset of rational numbers, and vice versa. Rational numbers are not a subset of irrational numbers. They do not overlap at all. Okay? Now, let's start with the most basic of rational numbers, of the rational number subsets. That's a natural number. Okay? So, let's see all of our natural numbers here. So, we have 12 divided by 5. This is a fraction, yes, and you may think it's a rational number, but when we go ahead and divide this, it actually simplifies to 4. So 20 divided by 5 is equal to 4. So this is a natural number. Okay, we also have 22. If we look outside and we see 22 trees, it could be observed. Okay, so that's also a natural number. All right, and that looks like that's pretty much it in this for natural numbers. Let's move on to whole numbers. Okay, so you just have to keep in mind that whole numbers are all natural numbers, but it also includes 0. So basically, the only thing we can really put here is 0, and that's it. Okay, natural numbers are also whole numbers. So natural numbers are a subset of whole numbers. Okay, let's move on to the next one. Our next one is going to be integers. So integers explain whole numbers, natural numbers, as well as their negatives. So the only thing I could put in here, since I already have my natural numbers and whole numbers, are negative numbers, negative whole numbers. Okay, so we have negative 8 over here. This would go right here. We also have, okay, so negative 18 over 2, yes, that's a fraction, but that could be simplified. That could be simplified to negative 9. So these will also be, this would also be an integer. Okay. Next, let's take a look at these rational numbers. So remember, rational numbers expresses numbers in the form a over b. So that's mainly your fractions that either terminate or go off in a predictable pattern. So we definitely have 1/3 here. Put this over here to the side. 0.66, it has that repeated sign over here, so that means it's going to be 0.666666 is going to go on forever. So this will definitely be a rational number. It could actually be expressed as 2 over 3, 2/3. Okay? 9/5. If we take 9 and divide it by 5, we won't get a whole number, so this will also be a rational number. Next, we have 0.222, and it's going to go on forever, okay? But since it's 0.222, it's going to keep that same predictable pattern. So this is actually going to be a rational number just because it's a predictable pattern. Next, we have negative 6.78. That's also going to be a rational number. And then lastly, we have 4.98, which is also going to be a rational number. Okay? Now, this leaves the irrationals. Remember, irrational numbers are not a subset of rational numbers. They're off to the side. So we do have pi, 3.14 blah, 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 blah. It's going to go on forever in an unpredictable pattern. And then we also have twice that unpredictable pattern because of the 2 here. And then over here, unlike this one here, there's not a predictable pattern. So it's 1.23684 dot dot dot. So that means it's just going to keep going on in an unpredictable pattern. And that's basically it. That's how we will classify the real number system using a diagram.